The last section of this change of concentration with time is a half-life of a zero order. Again, it has to tell you in the problem what the order is. You just have to read for it. And it says, what is the half-life? So that's my key that I'm going to use the half-life equation. It wants to know what it is in seconds. It tells me that the initial concentration, so it doesn't tell me what it is, so I'm just going to use the generic A, is 131 milligrams per liter. And I have a rate constant of 0.34 milligrams per liter seconds. So it wants it in seconds. I'm already in seconds. So the equation for a half-life of zero order is the initial concentration over 2 times the rate constant. So t to the 1/2 is going to be the 131 divided by 2 times 0.34. And when I do this, I get 192.6 seconds. If I want that just to 3 significant figures, it would be 193 seconds is my t to the 1/2. Okay? So you have to know the equation that goes with the half-life. I don't label them as being first order, second order, or zero order. You have to know which one is which. The next thing we'll look at is graphing the kinetic data. So if I graph different things, and what I mean by different things is that this one is the concentration. This one here, this is zero order, and it's the concentration versus time, and the slope is equal to negative k. I get a straight line. If I plot natural log of concentration versus time, again, the slope is a negative k, and it gives me a linear line. Or I plot 1 over the concentration versus time, the slope is equal to k, and I get a straight line here. So let me show you an example of that. Well, let me show you how you derive it for the first order. Let me start there. So the linear equation is y is equal to mx plus b, where y is, this is the y-axis, that's the x-axis, m is slope, and b is intercept. So for the first order, where I have the natural log of at over a naught, and there's a parentheses around that, is equal to negative kt. When I have a fraction and a log or natural log, I can separate those by subtracting them. So if I want to separate this fraction, all I have to do is subtract the two terms. So the natural log of at minus natural log of a naught is the same thing as this, is equal to negative kt. Now I'm going to add the natural log of a naught to both sides, so I get natural log of a times t is equal to negative kt and natural log. And this is my linear equation. So this right here is y, this is m, this is x, and this is b, which is shown here. So y is the natural log of at, the slope is a negative k, x is the time, and the intercept is a natural log of a naught. For second order and zero order, they're basically already into a linear equation formula. So for this graph here, I made an Excel file. I'm going to show you, this is the data that was on that graph, on that PowerPoint. And it was a figure out of the textbook at 13.9. So here's the time that they gave you, and they gave you the natural concentration. So I entered, these are literally numbers, I just entered those numbers in there. And then for the natural log, I took the natural log of the concentration, I got this. And to get the 1 over the concentration, I took 1 over, again, the concentration that was given. And so I did that for all these. And for zero order, blow this one up for a second. For zero order, what is it behind? Okay, it's not making it in front. What you see here, this is just the concentration, this is the time, and these are my individual points, and it shows me in Excel what's plotted here. When I made a linear line, trend line, through this, you see that not all my points are touching this line. This one's not on the line, this one's not on the line, this one's not on the line, this one's not, and that one's not. Okay, so it's not zero order because these do not touch that line. When I go to second order, this is the last one I made. Let's see if it's on top. Yes. Okay, when I do second order, which is again 1 over the concentration, you see that this one's not, again, I did the same thing. I just added a trend line to this. Oops. I added a trend line to this, and you see that I have a bunch of points that are not on the trend line. Here, 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 and here. However, when I plot natural log versus concentration, this one's probably not going to be on front top. Nope, it's not. Okay, when I plot natural log versus concentration, so this is natural log, so you see here what it's plotted. It's plotted the column with the natural log calculation and versus the time, and you see that all of the points are on the linear fit line. So I can tell by plotting the data, where I measured the concentration versus time, and plotting the different types, I can tell you that this reaction was a first order reaction because it's the one that when I plotted the natural log versus time, I got a linear equation. And that's what this is showing. This is plot 13.9, but they didn't show you the ones that didn't fit. They only showed you the one that did fit. So this is table 13.2 in the textbook, and it gives you what the rate law is for zero order, first order, second order. It tells you what the integrated rate law is. So these equations are given to you, and these equations are given to you, but I don't identify that that's zero order, first order, or second order. You need to be able to recognize that this one is 0, this one is 1, this one is 2, this one is 0, this is 1, this is 2. And it also tells you here that when I plot the concentration versus time, I get the straight line. The natural log versus time, natural log of concentration versus time, or 1 over the concentration versus time. So that leads me to the question of, here. So to find the rate constant for a first order reaction, I should plot what? So first order, it's going to be natural log of the concentration. For a second order, it's going to be it's going to be 1 divided by the concentration. And for zero order, it's just going to be the concentration. So this is a good multiple choice type of question where I can ask you, or short answer where I ask you to fill in the blank, or if I give you a plot and I ask you to identify what type of order it is, you look at the y-axis, see what's plotted, and identify it as being either first order, second order, or zero order. And that is the end of the change of concentration with time section.